This is part 2 of the double replacement reactions video. In part 1, we talked about acid and base neutralization reactions. We also looked at the general equation for a double replacement reaction, and we reviewed all the information that you need to use to solve or predict products in our reference table. Please make sure that you have your reference table available to you to complete this video. You will especially need page 6 and the solubility rules that are found at the top of that page. With this type of double replacement reaction that we're going to be discussing in this video, you need to remember what aqueous means. Remember that aqueous will be represented with an AQ, and it means to be dissolved in water. In your reference table, this will be a type 4A double replacement reaction. Okay, so in an aqueous solution, that means that you are dissolved in water, and you have to look at your solubility rules to determine your products. The solubility rules can be kind of tricky, so be very careful with how you read the solubility rules. In this video, I'm going to go through predicting products for this type of chemical reaction, and I'm going to be referring to the solubility rules. So if you do not have them out in front of you, parts of this video will not make sense. So please have those out. In this type of double replacement reaction, you must produce a solid as a product. If you do not have a solid, there will not be a reaction. Remember, if we're going to indicate a solid, we have to put an S for solid in as a subscript behind the chemical formula. If there is no solid, we are going to write no reaction, and we can abbreviate the word reaction with RXN. Okay, so we're going to try to predict some products for double replacement reactions. Make sure you have your solubility rules in front of you. Okay, we are going to do number 1 and 2, 3, and 4. So let's get started. Here we have silver sulfide and copper 2 chloride. We're going to use the trick that we used in the first video to predict our products. We're going to match our outside elements together and our inside elements together. Okay, so I'm going to pair silver and chlorine together. I need to make sure that their charges equal 0. Remember that silver always has a +1 charge, and chlorine has a -1 charge. So their charges balance out to equal 0 to give us silver chloride. Leave yourself some space here so that we can write if it is a solid or if it's aqueous after checking the solubility rules. Our next product is going to be copper and sulfur. Now, copper is a transition metal, so we have to determine its charge in this compound. In this case, it is 2. If I have 2 chlorines here, that must mean that copper's charge is a +2, so that they balance out to equal 0. Here's copper. Copper has a +2 charge. Sulfur has a -2 charge. Therefore, your formula for copper 2 sulfide is CuS. Now let's balance this equation. I'm going to do minnow, metals, ions, nonmetals, oxygen, and hydrogen. I'm going to start with metals. I have 2 silvers here and I have 1 silver here. So I'm going to place a 2 for a coefficient to balance it out. I have 1 sulfur as a reactant, 1 sulfur as a product. 1 copper as a reactant, 1 copper as a product. 2 chlorines as a reactant and 2 chlorines as a product. I have balanced this chemical equation. Now let's decide if we are producing a solid here. I need to look at my solubility rules. I'm going to look at my solubility rules on page 6, and I'm going to find anywhere where it says something about chlorine. If I look at the second bullet underneath soluble, it says all chlorides are soluble, except for when it's paired with silver. Here in this formula, we have a chlorine, but it's paired with silver. Therefore, it will be a solid. It is insoluble when chlorine is paired with silver. Okay? Then we're going to look to figure out about copper sulfide. If I find the third bullet underneath insoluble, it says all sulfides are insoluble except for group 1, group 2, and ammonium sulfides. I don't have any of those. So that means that this is insoluble. Now this is not going to work for us because in order for a double replacement reaction to happen, I need to have one product that is aqueous and one product that is a solid. Since I have two solids here, this reaction will not occur, so I'm going to write no RXN for no reaction. Okay, so this reaction will not occur. I know that seems like a lot of work just to find out that this reaction doesn't occur, but practice makes perfect. Alright, here is our next chemical equation. I have lead 2 nitrate and iodonic acid. I know this is an acid because it starts with hydrogen. I'm going to use our neat little trick to predict the products. I'm going to have lead and iodine paired together. Now lead is considered a transition metal, so I have to figure out what its charge is. Its charge is 2. When I pair it with iodine, iodine has a -1 charge. So my formula for lead 2 iodide is PbI2. Leave yourself some space here to write an S or an AQ after checking your solubility rules. And then the next product we have will be hydrogen and nitrate together. Hydrogen has a +1, nitrate has a -1. So their charges balance out to equal 0. So your chemical formula for nitric acid is HNO3. Now I am going to balance this chemical equation using MnO, starting with my metals. I have 1 lead here, 1 lead here. Now I'm going to do my ions. I have 2 nitrates and then 1 nitrate. So I'm going to balance this by placing a 2 here. So now I have 2 nitrates. I have 1 hydrogen and 2 hydrogens. So I'm going to place a 2 here to balance this out. So now I have 2 hydrogens on both sides. 2 iodines and 2 iodines. So now I am balanced. Now I'm going to use my solubility rules to determine which one is the solid and which one is aqueous in order for this reaction to occur. So I'm going to look for iodine, where it says iodine in the solubility rules. If I look at the second bullet underneath soluble, it says that all iodides are soluble except for when it's paired with silver, lead, or mercury. Well, my iodine here is paired with lead, which means it will be insoluble, so it will be a solid, because I will not be able to dissolve that in water. My next product here is nitric acid. So I will look for anything that says something about hydrogen, which is in group 1, or nitrate. And if I look at the first bullet underneath soluble, it says that all nitrates are soluble. It also says all group 1s are soluble, and hydrogen's in group 1. So this will be soluble. Since it's soluble, I'm going to write AQ. So I have a solid and I have something that's aqueous, so this reaction will occur. Okay, so I would write a star somewhere on your paper or on your notes just to remind yourself that solid, this little S, does not stand for soluble. Okay, this little S means solid, which actually means insoluble. A lot of students get this confused when they are first learning how to do their solubility rules. So it's always a good thing to write down in your notes or even write it in your reference table that you'll write an S next to everything that is insoluble. Okay? And you're going to write an AQ, which means aqueous, for anything that can be dissolved in water. So AQ means that it is soluble. Okay, so write this down somewhere, write it in your reference table, Write on your notes. Pause the video so you can have time to do that. Okay? Let's do one more, and then I'm going to let you try to do number 4 on your own. Okay? So we have copper and sulfur plus potassium and chlorine here. I'm going to use my neat little trick for my outsides and my insides. So copper and chlorine are going to be paired together. Now copper is a transition metal, so I have to figure out what its charge is. Well, I know sulfur has a -2 charge. I don't see any subscripts down here, so that means copper's charge has to be +2. Now, why does that matter? It matters because when you're writing your formula for copper and chlorine together, copper has a +2 charge and chlorine has a -1 charge. So you're going to need 2 chlorines to balance out your copper. Leave yourself some space here so that you can write if it's a solid or if it's aqueous. And my next product is going to be potassium and sulfur. This is an ionic compound, so I'm checking my charges. I sound like a broken record. I've said it over and over again. Potassium's a +1. Sulfur is a -2. So I'm going to need 2 potassiums to balance out that sulfur. And then I'm going to leave myself some space out here so I can write if it's aqueous or a solid. I'm going to balance this chemical equation next. I'm going to use Minnow, starting with the metals. Copper is a metal. I have one here and one over here, so they're balanced. Potassium is a metal. I have one potassium as a reactant and 2 as a product, so I need to balance that, and I'm going to put a 2 right here in order to do that. Sulfur, I have 1 sulfur as a reactant, 1 as a product. I have 2 chlorines as a reactant and 2 chlorines as a product, so I'm balanced. Now I'm going to look at my solubility rules to decide which one is the solid and which one will be aqueous. I'm going to start with copper chloride. If I find the second bullet underneath soluble, it says all chlorides are soluble except for when paired with silver, lead, or mercury. My chlorine is paired with copper, so it will be soluble. And remember, soluble means aqueous, so I'm going to write an AQ here. Now I'm going to look at potassium sulfide. If you find the third bullet under insoluble, it says all sulfides are insoluble except for when it's paired with a group 1, a group 2, or ammonium. My sulfur is paired with potassium, which is in group 1. Since it is in group 1, that means it is soluble. If it's soluble, I have to write an AQ. This is not going to work out for me because I have 2 things that are aqueous and I need one of these to be a solid. So since there are no solids here, this reaction will not occur, and I'm going to write no RXN for no reaction. I want you to do number 4. And when you do number 4, I want you to email me your answers. So predict your product, balance the equation, and then determine what is the aqueous product and which one is the solid product using your solubility rules. Email me with your answers. If you are lost or if you are confused, make sure that you talk to your classmates and maybe somebody can help you. Email me with any questions you might have. Good luck!